Imagine drilling deeper into the Earth than any human has ever gone before. Not just a few meters, not a few kilometers, but over 12 kilometers straight down into the planet's crust. That was the goal of one of the most ambitious scientific projects ever attempted. For years, everything was going according to plan. The drilling continued, records were broken, and scientists believed they were on the edge of discovering something revolutionary about the Earth's structure. But then, without any dramatic announcement or clear explanation to the public, the project suddenly stopped. The deepest hole ever created by humans was abandoned. And to this day, people still ask the same question. What exactly did they find down there? The project began during the Cold War, a time when the world was divided and both sides were competing not just in space, but also in science and technology. While one side focused on reaching the moon, the other decided to go in the opposite direction, down into the Earth. This led to the creation of the Kola superdeep borehole, located in a remote region of Russia. The idea behind the project was not mysterious or secretive in the beginning. Scientists wanted to study the Earth's crust, understand its composition, and gather data that had never been accessible before. It was purely scientific, at least on the surface. Drilling began in 1970, and over the next 2 decades, the project pushed boundaries that were once thought impossible. The deeper they went, the more difficult the process became. Temperatures increased, pressure intensified, and the equipment had to be constantly upgraded to survive the extreme conditions. But despite these challenges, the team continued. Eventually, they reached a depth of around 12.2 kilometers, making it the deepest man-made hole in history. At that depth, the environment was unlike anything humans had ever encountered directly. The temperature was expected to be high, but what they found was far beyond predictions. Instead of the estimated 100 degrees Celsius, temperatures exceeded 180 degrees Celsius. This created serious problems. The drilling equipment was not designed to handle such extreme heat, and materials began to fail. The deeper they tried to go, the more unstable the situation became. Officially, this is where the explanation ends. The project was halted because the temperature was too high, making further drilling impossible with the technology available at the time. On paper, it makes sense. Extreme heat, technical limitations, and increasing costs forced scientists to stop. But for many people, that explanation never felt complete. Because something else happened during the later stages of the project, something that was not part of the original plan. As the drilling reached extreme depths, researchers began to notice unexpected anomalies. The rock structure did not behave the way they had predicted. Instead of becoming denser and more compact, certain layers appeared fractured, almost as if they had been affected by forces that were not fully understood. There were also reports of unusual gas emissions being detected during the drilling process. These gases were trapped deep within the Earth and had not been released for millions of years. Their composition raised new questions about what was really happening beneath the surface, but the most controversial part of the story came from claims that were never officially confirmed. According to some reports, sensitive instruments picked up strange vibrations from deep within the hole. These were not typical seismic signals. They were irregular, inconsistent, and difficult to explain. Some described them as noise patterns that did not match any known geological activity. This is where speculation begins. Over time, rumors started spreading that the drilling team had recorded something unusual, sounds coming from deep within the Earth. These stories claimed that when microphones were lowered into the borehole, they picked up what some described as human-like sounds, distant and distorted, but unsettling enough to raise concern. The idea quickly spread, and people began to connect it to something far more dramatic. The theory that they had somehow reached a point that revealed something unnatural, something hidden beneath the Earth's surface. However, it's important to separate fact from fiction here. There is no verified scientific evidence that such sounds were ever recorded in the way these rumors describe. Many experts believe these stories were exaggerated or completely fabricated over time. But the reason they became so popular is simple. The mystery of the project ending without a clear, detailed public explanation left space for speculation. And when there is a lack of clear answers, people tend to create their own. Even without the rumors, the project itself revealed something surprising. Scientists discovered that at extreme depths, water existed in a form that was completely unexpected. It wasn't liquid water in the traditional sense, but rather water trapped within minerals under intense pressure. This changed the way researchers understood the Earth's crust and its composition. They also found microscopic fossils at depths where life was never expected to exist. These fossils dated back billions of years, suggesting that the history of life on Earth might be more complex than previously believed. These were major scientific discoveries, and yet they were overshadowed by the sudden end of the project. Why stop completely? If the goal was scientific discovery, why not continue with improved technology later? Why seal the site? Why abandon something that had already achieved so much? These questions continued to grow over time, especially as interest in the project resurfaced years later. Today, the Kola superdeep borehole still exists, but it is sealed. The site is no longer active, and most of the equipment has been removed. What remains is a small, almost unremarkable location that holds one of the most ambitious scientific efforts ever attempted. But despite its current state, the story of the borehole continues to attract attention, because it represents something more than just a scientific project. It represents a limit, a point where human curiosity pushed as far as it could go, and then stopped. Whether that limit was caused purely by physical conditions or something else entirely is still debated. But one thing is clear. Even after reaching 12 kilometers into the Earth, we have barely scratched the surface. The Earth's crust alone can be up to 70 kilometers thick in some regions. Beyond that lies the mantle, and beneath that, the core. Compared to the size of the planet, the deepest hole ever drilled is almost insignificant. Which means there is still so much we don't know, and that uncertainty is what keeps the mystery alive. Because the deeper we try to go, the more we realize how little we understand. Because the deeper scientists went, the more the project stopped behaving like a normal scientific experiment, and started turning into something far more unpredictable. At extreme depths, the Earth does not act the way we expect it to. The pressure is immense, the temperature is extreme, and the physical properties of materials begin to change. What seems stable on the surface becomes unstable underground. Metals weaken, rock behaves differently, and even small miscalculations can lead to massive problems. As the drilling crossed to deeper levels, the team working on the project started facing continuous technical failures. Drill bits that were designed to handle high pressure began to wear out much faster than expected. Equipment had to be replaced frequently. Progress slowed down. Every additional meter required more time, more effort, and more resources. But this was not the only issue. One of the biggest surprises came from the temperature itself. Before the project began, scientists had estimated the heat levels based on existing geological models. According to those models, the temperature at 12 kilometers depth should have been manageable within certain limits. But the reality was completely different. The temperature rose far beyond expectations, reaching levels close to 180 degrees Celsius. At that point, the environment was no longer just difficult, it was nearly impossible to work in. Drilling fluids, which are essential for cooling and stabilizing the drill, started to fail under the heat. The rock at that depth became less solid than expected, almost behaving like plastic under pressure. Instead of breaking cleanly, it deformed. This made drilling even more unstable and unpredictable. And when the ground itself starts behaving in ways you cannot fully control, the risk level increases significantly. But despite all these challenges, the team did not immediately stop. They tried to adapt, they tried to push further, because the deeper they went, the more valuable the data became. Every new layer revealed something that had never been observed directly before. Every sample provided new information about the Earth's composition, and from a scientific perspective, stopping meant losing the opportunity to explore further. But there is always a point where continuing becomes more dangerous than stopping. And for this project, that point came unexpectedly. Because beyond the technical failures and environmental challenges, there was another factor that made the situation more complicated. Uncertainty. We have explored space. We have mapped the surface of the Earth. We have built technology that connects the entire world. But when it comes to going deeper into our own planet, we have barely begun. And maybe that's what makes this story so interesting. Not what we found, but what we couldn't reach. Because sometimes the most important discoveries are not the ones we make. They are the ones that remain just out of reach.